I hope this is our last kinematics video, number 5, and I drew a picture for you here, so hopefully I cover these most difficult questions in one video. It's gonna be rocket question here, Santa sliding out the house, coming out of the chimney, and maybe a few other questions that are longer and will take time, and probably the most difficult that you will see in our course in kinematics. We'll see there are other challenges and other topics we cover. So this one is gonna cover the rocket problem and the Santa problem. And let's start with Santa question. After delivering his toys in the usual manner, the jolly old Santa wishes to have some fun and slide down the icy roof as shown. He starts from rest at the top of the roof, which is 6 meters length. So this part is 6 meters. 6 meters length, and accelerates at the rate of 4 meters per second squared. So his acceleration right here is 4 meters per second squared. The edge of the roof is 3 meters above a soft snow bank. So this part is 3 meters, and which Santa lands on. So find the total time Santa is in motion before he lands, and the distance, how far does he fall? So this distance needs to be found. So because I have on the sliding part, because I have the distance and I have acceleration and the initial velocity is 0, I can use the DAF formula to find the final velocity. So here I'm gonna call this one final velocity. Let's call it not final velocity because the final is going to be when he lands. Let's just call it velocity. So I'm going to find this velocity, but it is final velocity for that part of the trip. So this velocity is going to be equal to the square root of 2, acceleration is 4, and the distance is 6 meters. And it is 6.9293, 693 meters per second. And I'm going to redraw this velocity maybe on the side right here. So this is your velocity. And they give you an angle of 30 degrees right here with the horizontal. So I have this angle, so I'm going to make horizontal component of that velocity, vertical component of that velocity, an angle of 30 degrees or theta. So this part is going to be v cosine 30, and vertical is going to be, so this is vx, and vy is v sine 30 degrees. So I'm gonna calculate it here. So Vx is V cosine 30 and equals to 6 meters per second. And Vy is V sine 30, gives me 347 meters per second. So to find the time it took to go over the first part, so I'm going to call it time t1, so to get to the bottom of the roof, is equal to change of the velocity over the time, over acceleration, and acceleration is given. So the velocity final is 693. So 693. Initial velocity was 0, and acceleration was 4 meters per second squared. So t1 is equal to 173 seconds. So that is the first part. Now I have to look at the rest of the path a little bit differently. So I'm gonna erase this right here, and make it a little bit smaller. So here is the roof and here is the house. So this velocity is 693. I have horizontal component, I have vertical component, and the angle is 30 degrees. We just calculated that one. So this is my Vx, this is my Vy. And now I'm gonna switch to different colors so it makes more sense. Let's do purple. So now he starts going like this and lands with some vertical velocity. So it will have, his horizontal velocity is gonna stay the same, but it will have a different vertical velocity. So his initial vertical velocity is right here, Vy, and this one is going to be some different vertical velocity. So I'm going to call this vertical velocity V final. And this V final depends on vertical initial velocity, which is Vy. So it will have this initial velocity Vy. Again, I have the distance 3 meters, so the height of the building is 3 meters. And I know acceleration due to gravity is 10, so it's that formula. So I have the square root of 2, acceleration due to gravity 10, the distance is 3 meters, but it starts with initial velocity, vertical velocity, which is 347 squared, and that will give me velocity of 8.5 meters per second. 8.5 meters per second. So I figured this velocity out, and now I can figure out the time it takes the second part to fall from the edge of the roof to the ground. So that time 2, is equal to change of this velocity on y over the time of acceleration. Sorry. Over acceleration, and now acceleration is 10. So my final velocity is 8.5. Initial vertical velocity was 347, and acceleration is 10. So that gives me time 0.5 seconds. So the total time when they ask you, let me maybe change different colors here, I'm going to do it in blue. So the total time Santa is in motion is the sum of these two numbers. So it looks like it's going to be 223 seconds. Now I have to figure out the distance. How far does he land? So I'm going to do that one in red. So now I'm going to calculate this distance. How far does he land? So this distance is equal to Vx, which doesn't change, horizontal velocity is going to stay the same, times the time that it's going to take to fall. So Vx is 6, and the time to fall is 0.5. So that gives me 3 meters. So Santa is gonna land 3 meters away from the building. So here is gonna be 3 meters. So I have 2 answers that they asked me. There are more questions on Santa online, so you should practice more questions and check your answers. But let's do one of the rocket's questions as well. So rocket is, actually this question was given at CSU San Diego their midterm as their midterm or final. I think it was a midterm. One of the former students emailed me and gave this question. So this, just to tell you what kind of difficulty questions you will see when it's going to be a final or a midterm. So at the university, a rocket is launched straight up with constant acceleration. 4 seconds later, after the liftoff, a bolt falls off the side of the rocket. The bolt hits the ground 6.9 seconds later. What is the acceleration of the rocket? So we're going to draw a rocket path. So we will have the rocket is moving in some motion. So I'm going to do it like a parabola, but it doesn't have to be parabola. We know it's not a parabola because the bolt just falls off. So at first I'm going to have this part, and I'm gonna call it, these are the 4 seconds, first 4 seconds. So these are the 4 seconds, and I don't know what acceleration was. They asked me what the acceleration was. So I know if the initial velocity was 0 meters per second, then the final velocity, I'm going to write the formula here and I'm going to erase it. The final velocity says it's initial velocity plus the acceleration times the time. Initial velocity is 0, acceleration I don't know, and the time is 4 seconds. So the final velocity for the first part of the path is going to be 4a, because it's 4 seconds and acceleration is a. So the velocity here is 4a. And I don't need it, the formula right now, because I need space to write other things. So I'm gonna stop right here. Then this is the initial velocity of the bolt after, let's change the color maybe to purple. So this is the initial velocity of the bolt as it is traveling without the rocket. So now I need to find the time it will take before it stops all the way on the top. So the time is going to be change of the velocity over acceleration, and acceleration is it's falling down. So the final velocity minus initial velocity over the acceleration is -10. So that gives me time is equal to 0.4a. So this will be the time, how long it will take for the rocket to get to the top before it stops. Oh, no, not the rocket, the bolt. Let's figure out the distance it traveled. So I'm going to figure out the distance traveled here, and the distance traveled over here. So let's call this distance 2 and this distance 1. So I'm going to say distance 1 is equal to average velocity, which is 2a, 4a plus 0 divided by 2, 2a, times the time, 4 seconds. So distance 1 is 8a. Distance 2, so that is distance 1. Distance 2 is, again, average velocity is 4a, because at the top is going to be 0 and initial is 4a, so it's 2a, average velocity. And the time we figured out is going to be 0.4a. So this is 0.4a. So distance 2 is equal to 0.8a squared. Okay, now they tell you that, let me switch to different color again. I'm gonna do brown. The time it takes for it to fall on the ground is 6.9 seconds. So from the moment here where it gets lost from the rocket to the moment it falls down is 6.9 seconds. So this path is 6.9 seconds. But I am spending 0.4a seconds before it stops. So the time left here, let me write it maybe differently. I'm going to write it on the side. So the time left here is 6.9 seconds minus 0.4a. So this is the time to fall from all the way on the top to all the way at the bottom. So since I know the time it takes to fall on the ground, I can figure out this velocity. This final velocity is equal to initial velocity on the path down, which is 0 all the way at the top, plus acceleration, which is 10, times the time. And the time is 6.9 minus 0.4a. So that is my final velocity. Now I'm going to calculate the distance right here, and I'm going to call this distance d. So this distance d is equal to average velocity. Initial velocity is 0, and final is the one that I just found. So average is going to be 0 plus this divided by 2. So I have 0 plus this, which is 10, and then 6.9 minus 0.4a divided by 2 times the time. But the time is 6.9 minus 0.4a. So I have the distance is equal to 5, 6.9 minus 0.4a squared. But this distance, the one that I just wrote, this distance is equal to d1 plus d2, because it consists of this part and this part. So I can say it equals to 8a plus 0.8a squared. So now I'm gonna solve this equation to find acceleration. So what I have is this: 5, 6.9 minus 0.4a squared is equal to 8a plus 0.8a squared. For this part, I'm gonna use binomial squared. So if I have a minus b squared, that is a squared minus 2ab plus b squared. So I will have 5, 6.9 squared, 47.6 minus 2 times their product, 552, 552a, and plus 0.16a squared equals to 8a plus 0.8a squared. Now we're going to distribute it. I have 238 minus 27a plus 0.8a squared and equals to 8a plus 0.8a squared. I see 0.8a squared from both sides. Then I'm gonna add 27 to the other side, so I have 238 is equal to 35a if I add 27a to the other side. So a is equal to 6.8 meters per second squared. So this is how I find acceleration. Online you have more different ways solved, more questions which you can practice by maybe watching this video again if you need more help and understand and practice more. Try to solve questions without watching the video, but then if you get stuck you can always come back. And also I have posted questions online, different types of questions. One is algebra way, another student brought it and showed me, so I thought I would post it for you. And then another 2 different ways of calculus based solving this question. So all those questions are posted for you online in step-by-step solutions for our problems from PDF files. Here's one more question that I want to do with you before the video is over, and I might be able to have a little bit time left and I will do some easier question. A person fires a pea gun at a hanging from a ceiling at distance h vertically above the gun and a distance d horizontally away from the gun. The person aims, so this is the distance that they say h. So from here, from the gun, this distance is h. this part is h, and distance d away from the gun, so that is distance d. And the person aims directly at the can and fires. But just as the person fires, the can is released. If the initial velocity of the P is v sub 0, so this velocity v sub 0, how long will it take for the P to hit the can, and what distance will the can fall before the P hits it? So I can break my initial velocity into Vx. So I'm going to call this one Vx, and Vy, and this is some angle theta. And because he aims right at the top of this triangle, I can say that my tangent theta is equal to h over d, or theta is equal to arctangent h over d. And just to remind you, I think I mentioned in the previous videos, maybe like 70–60% of questions you're going to have on AP exam are going to be formula based, so they won't give you the numbers. Like in this problem, there's no numbers, so you have to be able to derive the formulas and know how to work with the formulas. So I do not know what theta is, but I can figure it out because I know that he was aiming right at the top of that triangle, and they tell me the h and the distance of that triangle. Also, I know that Vx is going to be v sub 0 cosine theta, the one that I just found, theta, and Vy is going to be v sub 0 sine theta. Then to figure out the time it's going to take to travel this path, so the time is the distance over the average velocity, so that's the distance over Vx, and Vx doesn't change. So the distance over v sub 0 cosine theta, v sub 0 cosine theta. Also, from the given triangle, the hypotenuse, this part, is h squared plus d squared. So that is the length of this part of that right triangle. So here is the right triangle, and the hypotenuse is d squared plus h squared. So instead of having my cosine here, I can plug in the d and h. So that is distance divided by v sub 0, and cosine is the adjacent over the hypotenuse, which is d, over the square root of h squared plus d squared. But when you divide by, it's the same as multiplying, so I can erase this part and rewrite right here the square root of h squared plus d squared. Because if I have a fraction, divide by another fraction, and another fraction is the square root, so it's the same as this fraction times the square root over that d. Okay, so I figured this part out. Oh, and I can cancel d. So if I cancel d's, did not mean to erase it. If I cancel d's, then the time before it reaches the line where the can is going to be falling down is going to be the square root of h squared plus d squared divided by v sub 0. And these are the information that are given so far, so I can use these numbers if they were given to solve the problem. So that answers the question how long it will take before P hits the can. So that is your A, the first part. And for your B, let's do it in different color. what distance will can fall before the P hits it? So if I know the time for how long the can has been falling, I can find out the velocity of the can right before it gets hit. So the velocity of the can before it gets hit is initial velocity is 0 plus acceleration, which is g, times the time, and I just figure out the time. That's the square root of h squared plus d squared over v sub 0. So that is the final velocity, but to find the distance that's been fallen down, I'm going to call this distance h, so the distance it travels before it gets hit. So h is equal to average velocity, so that is g square root of h squared plus d squared divided by v sub 0 and divided by 2 times the time, and the time is the square root of h squared plus d squared divided by v sub 0. So I would have h is equal to g over 2v sub 0 squared and times h squared plus d squared. Or in other words, it's the same as g over 2, and because this part, the square root of over v sub 0 is t, I could just say t squared, because you have this and square root times the square root, so that could be just t squared. So this is this question. It's pretty common to see this type of questions on your university's exams, so it's good to know how to solve this question. And then I have time for one more question for you in this video. Here's one last question. I'll go ahead and pause it because I don't want to take time to read this question for you. I only have like 2 minutes left to solve it, but I want to give you the basics of how to solve this question. So pause it, read it, and then let's talk about it. So here we have the first incline is 9 meters and acceleration is given 0.5 meters per second, and the distance is given 9 meters. So I can figure out the final velocity of the ball by the time it reaches the first incline. Then this is going to be exactly the same velocity, 3 meters per second, for the second incline. And the final velocity is going to be 0 meters per second. So I can figure out the time it's going to take because they give me that this incline is 15 meters. So this incline is 15 meters. So I can figure out the time it's going to take to get to the top. So if I plug in the numbers, it gives me 10 seconds. It's distance over the average velocity, and average velocity between 3 and 0 is 1.5. So I got 10 seconds. Then I need to figure out the acceleration in the second part, on the second incline. So I see the acceleration in the second incline is negative 0.3 meters per second squared, because it's the average it's the change of the velocity divided by the time, and the time is 10 seconds. Then they ask you how long does it take to roll the second plane. This question, I'm gonna make it in red. What is the ball speed 8 meters along the second plane? So maybe somewhere right here is 8-meter mark, and I am looking for that velocity. I know acceleration and I know the distance, correct? So I can figure out that velocity at that point. So for the second incline, I have the square root of 2, acceleration is negative 0.3, and the distance is 8. But the initial velocity is not 0 in this case. The initial velocity is 3 meters per second squared. And I get the velocity at 8 meters after it starts rolling up as 2.1 meter per second. And I hope this is our last kinematic video, unless you, on kinematics. Unless you ask me to solve any of the questions, I will add additional questions and videos related to kinematics. And the next video should be dynamics.